In math today, we are continuing studying fractions. We have been comparing fractions, but now it's time to talk about what happens if the fractions are equal. Today, we will begin with watching our Brain Pop Junior again.
Equivalent fraction.
You are focusing your eyes, ears, and brain, thinking about how fractions can be the same value, the same amount, but they can use different numbers.
This sandwich has 4 equal parts. You took 2/4 of the sandwich. That's the same as 1/2. Equivalent fractions are equal to the same amount, but use different numbers. What are some fractions that are equal to 1/2? Becca and Tasha are sharing a sandwich, and each gets half. Their sandwich has 6 equal parts. So each person gets 3 out of 6 parts, or 3/6 of the sandwich. You can draw pictures to help you see how fractions are equivalent. Mike and Brian are sharing a pizza. Their pizza has 8 equal slices. So each person gets 4 out of 8 slices, or 4/8 of the pizza. 4/8 is equal to 1/2. Maybe on this rectangle, 5 out of 10 equal parts are blue. If you look at the rectangle a slightly different way, you can tell that half is blue. So 5/10 is also equal to 1/2. What are some fractions that are equal to 1/4? 2 out of 8 parts of this quilt are yellow. That means 2/8 of the quilt is yellow. If you look at the quilt a little differently, you can see that 1/4 is yellow. So 2/8 is equal to 1/4. What fraction of the tiles is green? 3 out of the 12 tiles are green, or 3/12. You can also see that 1/4 of the tiles are green. So 3/12 is equal to 1/4. What are some fractions that are equal to 1/3? It's time for dessert. This cake has 6 equal slices. 2 slices have candles. So 2/6 of the cake has candles. If you look at the cake in a slightly different way, you can see that 1/3 has candles. So 2/6 is equal to 1/3. Did you eat the candles too? There are 12 eggs, but 4 of them are cracked. 4/12 of the eggs are cracked. If you group the eggs differently, you can see that 1 out of 3 equal groups are cracked. 1/3 is cracked. So 4/12 is equal to 1/3. You're trying to glue the eggs back together? Okay. Equivalent fractions can show the same amount using different numerators and denominators. It can be a little confusing, but you can draw pictures or build models to help you understand. Not that kind of model.
All right. We are learning about how fractions can have the same value. They can be equal, but we represent them using different numerators and different denominators. Next, we're going to watch a video from Mr. McKinney, and we're going to hear about how we're going to do our task today.
Take a look at this delicious cheese pizza. That is one whole pizza. There are no slices. Now there is one slice cut into two pieces. But is it still the same size whole pizza? Your answer should be yes. Even though I put a slice on the pizza, I didn't take away from any of the pizza. I didn't add to it. It's still the same size, but now it's just two smaller pieces instead of one giant piece. Now I cut it into four pieces, but it's still the same size whole. I'm just getting smaller pieces. And my pieces are still getting smaller, but again, my whole pizza is still the same size as it was from the very beginning. On the left, I have 1, 2, 3, 4, 5, 6, 7, 8. Each piece represents 1/8. And if I have all 8 out of 8, that is the same as one whole pizza. So if I still have all of my slices left, both of these pizzas are the same size. If I ate 4 pieces out of the 8, my fraction would be 4/8, which would also be the same as 1/2. This one is just cut up into smaller pieces. 4 is half of 8. I ate half of the whole pizza, and if we only cut 2 slices, 1 is half of 2. I ate half of that whole pizza. Notice that my bottom number on this side is 8, so that tells me that there are going to be 8 pieces total. My bottom number, my denominator, over on this side is 2, so that tells me there are going to be 2 pieces total. Even though the fractions are different, they can still be equal to each other. If I want to see if 4/8 is equal to 1/2, without looking at another picture, I can look right at my denominator, 2. I want to see if I can split this pizza up into groups of 2. And I can do that by taking one group of 4 in each, and another group of 4. So I took 2 groups of 4. So that tells me that if I ate this side, I ate 1 out of 2, which is known as 1/2, which is also known as 4 out of 8.
All right, let's join me on Seesaw, please. We're going to find our task together. And we're going to start working on
I'm not muting myself.
equivalent fractions. Please click on Activities, Assign to Class folder. And today we're looking at our blue folder for our math. Our task today is called Equivalent Fractions. You will see the Brain Pop video that we just watched together. Go ahead and open that up by clicking Add Response. Slide number 1 says with your teacher. Let's start by looking at the example on the left side. On the left side, we have two models that are the same size whole. I noticed that the one whole is equal in size because our models are the same size. That's very important when we are comparing equivalent fractions. Let's first look at the green model. The green model is partitioned into 6 equal parts. 1, 2, 3, 4, 5, 6. I notice my denominator already says 6. We are going to count the shaded parts today. I notice there are 1, 2, 3, 4, 1, 6 highlighted with green. So in my numerator, I notice it's blank. I can record 4 as my numerator. On the left with green, we are representing 4 1/6 or 4/6. Our purple model shows the same size whole, but I notice it is partitioned differently. I notice 3 parts, so our denominator is 3. And I notice that 2 of them are shaded. 1, 2 are being counted. Our numerator shows 2 because 2 parts are being counted. What we see here in this example is that 4 1/6 is equal to 2 1/3. They take up the same amount of space in the one whole. But we use different numbers for the numerator and denominator because of how the whole is partitioned. Let's move to the right. On slide number 1, let's do this example together. On the left, we are showing 2 1/4. Just like Mr. McKinney said, each part is the unit fraction. So when we shade 2 1/4, we combine it and we have 2/4. Let's look at the right with the green model. This fraction is easy peasy. This is a fraction you have been looking at and identifying since first grade. We know each part is 1/2. And we are counting the green part, the shaded part. So our numerator is 1. This model shows us that 1/2 is equivalent, it's equal to 2 1/4. Using that knowledge, I want you to try the examples on slide number 2. Go to slide number 2, please. On slide number 2, you have 2 examples. One on the left, another example on the right. I want you to fill in the missing numbers in the numerators. Show which fraction is equivalent by filling in the numbers. You have 1 minute to work on this problem, and then we will share out together. All right, let's go ahead and share out what we found out for slide number 2. What did we learn about these two examples? Let's start with the one on the left. I'm looking for a third grader who can share out what we learned about 2 1/8. What is it equivalent to? Looking at the example to the left, 2 1/8 is equal to, who can determine what that missing numerator is? Gloria, go ahead.
It is 1/4.
Thank you, Gloria. So we fill in 1. Whoops, let's try that again. To make it 1/4, because we see that each part in our model to the right is 1/4. That's the unit fraction. And we're counting one of the parts. 1/4 is equivalent to 2 1/8. If you look at your model, you will see that they take up the same amount of space. The same amount of area is shaded in 2/8 and 1/4. Our next problem is to the right. Who can share out what they determined? What did you figure out about this model and this model? Looking for a third grade friend who can share out with the class. Angela, go ahead. Angela, do you want to share out on the example to the right? Make sure your mic is unmuted, please.
So I think that there is one part shaded in this model and
Keep going.
2/6 is shaded in this model.
Amazing example. So on the left with the bluish purple, Angela says there's one part shaded. So our numerator is 1. That's because each piece, each part is the unit fraction. And we're counting one of them. Then Angela said to the right, we have 2 parts shaded. So our numerator is 2. We know that's correct because each part over here is 1/6. When we add up 1/6 plus 1/6, we get 2 1/6. We have just proven that 1/3 is equal to 2 1/6. They take up the same amount of space. Go to slide number 3, please. I want you to try slide number 3. Show me what you have learned by filling in the missing numerators and proving that these fractions take up the same amount of space, but they use different numbers. You have 1 minute to finish slide number 3. On slide number 3, you should have filled in the missing numerators. On the purple model, there are 6 shaded parts out of 8 total parts, so we get the fraction 6 1/8. The green model shows or represents 3/1/4 because there are 3 parts shaded and each one is 1/4. 3/1/4 is equivalent to 6/1/8. Let's move to the right. The yellow model demonstrates 1/2, which is equivalent to 2/1/4. We know this is true because each part is 1/4. When we add those together, we get 2/1/4. Great job. Let's go to slide number 4, please. Slide number 4 is showing equivalent fractions using a number line model. We have a question at the top that we have to answer by circling either yes or no. Let's look at the question together. Is 1/4 equivalent to 2/1/8? First of all, I notice this vocabulary word equivalent. That means equal. Is 1/4 equal to 2/1/8? Let's find out by looking at our model. Look at the top model. I see 1/4 is plotted or graphed on the number line. Now I'm going to look for 2/1/8. I see 2/1/8 is also plotted on the number line or graphed on the number line. I also can identify that both of these take up the same amount of space. Fractions that take up the same amount of space have the same value. They are equal. So we would answer this question by saying yes. I also would like you to write the comparison below, like this. 1/4 is equivalent to 2/1/8. Check that you have your model marked up like I do. Check that you have answered the question. And check that you have written the comparison. 1/4 is equivalent to 2/1/8. I want you to try number 5. Slide number 5 shows you a different question with different fractions. Is 1/2 equivalent to 5/1/6? You have 1 minute to show on your model, answer the question, and write your comparison. You have 1 minute and then we will share out together. Looking for a 3rd grade friend who can share out. What did we learn about 1/2 and 5/1/6? Are these two fractions equivalent? Do they take up the same amount of area or space? Do they have the same value? Haley, go ahead.
So I found out that 5/6 is bigger than 1/2 because it's more ahead than 1/2.
Thank you so much for sharing. Haley said 5/6 can be identified here, but 1/2 is here. When you look at the number line, the jump to 5/16 is much greater than the jump to 1/2. So our answer would be no. 1/2 is not equivalent to 5/16. Our comparison could be recorded like this: 1/2, 5/16. And Haley shared with us that 5/16 is greater than 1/2. So our symbol will show the opening by the greater number. Check that you have correctly answered problem number 5. Okay, I want you to go all the way down to slide number 15. 15. We're going to do one of these examples together so that when it's your work time, you know what to do. Everyone should be on slide number 15. Thank you. Thank you. So waiting on a few friends to join me on slide number 15 so we can do an example together. On slides 15 through the end of your task, you are given 2 equations. I noticed them right here. 4/16, 5/18. Your job is to figure out which vocabulary word goes into the blank. Your job is to determine, is 4/16 greater than 5/8? Is 4/16 less than 5/18? Or is 4/16 equal to 5/18? Today, you will build a model and you will drag the correct vocabulary words into the blank, just like this. So how can you build a model? We have our model tool, our fraction bar tool, on slide 13. On slide 13, you can find your fraction bar tool that we have used before. And I will also put the link in our directions when we are done with the Zoom. You will build 4/16 and 5/18, and then you will put a picture of your model here to determine which is greater than, less than, or are they equal to. Your job today, your independent work, is to finish all of the math slides. We stopped on slide number 5. You need to do the rest of the slides starting on number 6. I want you to try them. All of the slides. Remember, slide 13 and 14 has some directions for you of how you can use our tool and how you can take a picture of your model. These are tasks that you should be practicing on your own. When you get to slide number 19, this is a bonus. If you would like to click here, you may. This is optional. Slide number 19 is optional. When you are done all the way to slide number 18, doing all of the math slides, you will push the green check and turn in your work. Don't forget that today I will be on Zoom 12:45 for any questions you have. Starting at 12:45 is your math work time and my office hours. If you have a question, you can come onto Zoom and I will be here to answer your question. At 1:35, you have Zoom with Mrs. Katowitz. Her Zoom link is here on the schedule for you to join her class.